Well, thank you for joining us with this further maths Newton-Raphson session. We're going to look at a simple question which requires the use of Newton-Raphson as to solve a solution where find out where a root of an equation is. So let's have a look at this particular question. And the question starts by saying, show that the equation f of x equals 0 has a root alpha between 1.6 and 1.7. Well, what we have to do is if we substitute 1.6 into our equation, we have to get one of these has to be a positive and one of these has to be a negative, so that between 1.6 and 1.7 the graph is like it's crossing over, going from say a positive value to a negative value. I'm not sure which case it is, it might be the other one. So let's have a look at finding, first of all, part A, find a function of 1.6. That's 4 times cos 1.6 plus e to the negative 1.6. Be sure to set your calculator to radian because we are not using degrees, we are using units. 4 times cos 1.6 plus e to the power of negative 1.6. This is equal to 0.485 498. Let's substitute 1.7 into our function. Let's see what we get. 4 times cos 1.7 plus e to the power of negative 1.7. We get negative 0.3326944. Now, since the function of 1.6 is greater than 0, and combine that with the function of 1.7 is less than 0, there exists a root alpha between 1.6 and 1.7 such that the function of that alpha value will be 0. So that's just showing that the equation has a root somewhere between somewhere between 1.6 and 1.7. Now, part B asks us to use the Newton-Raphson procedure. So taking 1.6 as your first approximate to alpha, apply the Newton-Raphson procedure once to the function to obtain a second approximation to alpha. Give your answer to 3 significant figures. Now, in your formula sheet, don't expect to memorize this. You can go straight to your formula sheet on page 8 and you can see that x to the n plus 1 equals x to the n. The next x is the previous x minus. Substitute x of n into the function, substitute x of n into the derivative, and then you will get your second approximation. Well, we know what f of x is. What is the derivative? So f derivative of x now equals, now the derivative of cos x is negative sine x, so we'll say negative 4 sine x. The derivative of e to the power of negative x is negative 1 e to the negative x. So if we substitute 1.6, we have to use 1.6 to find the derivative. 1.6. Let's get that value. -4 sine 1.6 minus e to the power of -1.6. We get a value of -4.2. And therefore we can substitute now. We've got 1.6 minus the function of 1.6, which we've already got here. 0.085 over f dash 1.6, which we've got over here. 4.200. Let's see what we get. 1.6. What's going to be plus? We've got two negatives here. Negative and negative make it positive. .6 plus 0.08598, etc. Divide that by 4.20019.093, and we get 1.62026. Now we want three significant figures, so therefore to three significant figures is 1.62. Three significant figures. All right, so let's see how we went with our solution. Now we've got here function of 1.6 is 0.08. Function of 1.7 is -0.3. So they've just rounded it off to the first. So you can see we've got 0.08, -0.0, -0.3. And so you can see that we're okay. Now they've said one is positive, one is negative, or a sign change, therefore there's a rule. So we've mentioned one is negative, the other one is positive, the other is negative, therefore there exists a root between 1.6 and 1.6. Good. And the answer in the marking scheme states they found the derivative f dash of x is -4 sine x minus e to the negative x. And we found the same derivative here. And then they've substituted into the Newton-Raphson form and come up with, I haven't actually shown the answer here, 1.6 minus 0.085 over -4.2, and you can see that we've got the same minus 0.085 over -4.2, and therefore we will see that that's correct. And that's all this question requires you to do. Going back over it, we're looking for a value. One is positive, one is negative. The function of that value is positive, and the function of that value is negative. And then using our Newton-Raphson formula, please don't expect to memorize that. It's in your formula sheet, so you should be fine. Okay, so practice these and look until we see you again. Let us know how you go. If you find any others, just put it on Edmodo. And until we talk again, stay happy.